This is my home server. I rehoused it in a fractal design case because the case is very quiet and because I was looking to upgrade the number of hard disks, and my old case did not have the capacity for the extra drives. Cooling wise, there are 2 fans blowing air into the drives from the front. These are voltage driven by the case with 3 settings available: 6 volt, 9 volt and 12 volt. The 12 volt is audible. The others are not so, and so I was running it on the 9 volt settings. You can see the white fan at the back of the case, and that is also driven by the case voltage. There are black fans in the roof of the case and in the base of the case, and 2 on the processor fans. All of these are PWM controlled by the Mobo. This does make the airflow a little complex. However, the temperatures within the case are well under control. The processor core rarely makes it above 30 or 40 degrees, and the 2 spinny disks are rarely above 30. The only thing running above 30 degrees consistently are the 2 NVMe drives. I've been running this setup for a few months and I've had no temperature problems whatsoever. Then I fitted 4 extra drives and the summer came. The 2 fans, even running at full pelt with the front door open, could not keep the temps of a couple of the new drives below 40 degrees, which doesn't meet my requirements, which is to keep all the spinny disks below 40 degrees all the time. The NVMEs are also a little warmer than I would like, but they are still well within the operating temperature, which I think is about 60 degrees for these drives. For the spinny disks, they're rated between 5 and 50 degrees, so there's no problem, right? They're in spec, and I'm being unreasonable wanting to keep them below 40. Yes, I am being unreasonable. Not only do I want the drives to remain under 40, I want the case fans not to be running at full tilt and therefore not making lots of noise. In order to see if any mitigation is possible, I have decided to make use of the 5 1/4 inch bays. Hardware wise, I can use these 5 1/4 inch bay adapters with fan mountings to keep a constant airflow over the drives in these bays, albeit by default it's perpendicular to the natural airflow. This does create a problem though. I've run out of case fan ports. That is, I've already got a splitters on the fan controller for the case, and I don't really want to add 2 or 3 more onto that controller. Also, I would much rather the controller was a PWM controller to go with the PWM fans, but also because that enables me to set the speed to a happy place where it's producing enough cooling but also not making noise. Finally, I don't want to use the PWM controllers on the motherboard. I think there's a spare one, because of course those temperatures are motherboard temperatures, not hard disk temperatures, and I want to keep a constant airflow over the hard disks regardless of the motherboard temperature. I don't think, at least for the moment, I can take the temperature from the computer monitoring of the hard disks and convert that to a variable speed. However, I can probably create an independent PWM controller that runs at a constant speed of the fans, essentially trying to find that sweet spot between noise level and airflow. And so that is the task ahead of me. Figure out how PWM works for these computer fans, learn how to control it, move some of the spinny disks around inside my server, and find the correct or the best speed I can get in order to keep the temperatures as low as possible without too much noise. I've got this PWM fan here, and as you can see it's mounted on a hard drive bracket. So we're going to try independently controlling it from the motherboard using initially these two wires. So we can plug in the power onto these wires. We have 0 volts, and I think this is currently running about 4.5 volts. Oops. It definitely spins at 4.5 volts. That's pretty good. The airflow at that speed is not brilliant, but the fan does go round. So I'm going to whop up the voltage a little bit and we'll see what happens. So this is now running at 9 volts. There's a bit more airflow. Let's try it at 12. So we're now running at 12 volts. And there's a bit more airflow again. That's how the existing hard disk cooling fans in my computer case operate. There's a switch that selects the voltage and the fan speed alters accordingly. We have 2 additional wires. The green wire, I believe, is the sense wire. So that's the feedback to the computer as to what speed the fan's going at. I think I'm going to connect it up to the oscilloscope and see what we get. If I connect the sense wire while the fan's running at 12 volts, I get nothing, which would suggest to me that either I'm doing something wrong or the sense wire only works when the PWM's in operation. I could read the manual, but instead I'm going to put a signal on this wire and see what happens. So according to the specification, the frequency of the PWM signal should be 25 kilohertz and the voltage 5 volts. So we've got our little blue line there running at 25 kilohertz square wave, and what controls the speed of the fan is the duty cycle, which we can see in the left hand part of the window is set at 50%, and you can see that from the image anyway. I haven't actually connected it up yet. We will do that shortly, and we can still see that we've got nout coming out of the sense wire. So let's connect up the PWM and hopefully we won't blow up, and hopefully we won't damage the fan in any way, shape or form. Let's just touch it on for the start and see what happens. We're kind of getting a signal on the sense wire. I'm not sure that's fan slowed down. Should we take it off and see if it speeds up? Oh yes, there's definitely a speed difference there, isn't there? Let's change the duty cycle and make it less. Ah, right. So here we have a duty cycle of 5%. Let's see what that does. Well, I think we can safely say that the fans don't run at that speed, that duty cycle. So I've disconnected it. Let's rate it a bit more than that then, shall we? We now have a 20% duty cycle. Let's see what that does. Well, the fan is a lot slower, obviously. I'm just going to remove it now and see if it speeds up. Almost instant. So that's good. I wonder how low we can go with the duty cycle. I wonder if it'll go to 10%. So we're now at a 10% duty cycle. Okay, so if we take it as low as 10%, it doesn't work. So what does 15% do? This is a 15% duty cycle. And I would say that the fan will run at 15%. So the minimum speed we seem to be able to do at this point is 15% duty cycle, and if I remove the wire, which I've just done, that's running at maximum duty cycle, which I'm guessing is 100% duty cycle. That's okay. The sense wire, I'll put that back on again, comes into operation when there's a PWM signal on, and by the looks of it, it's just feeding back the PWM signal. From my point of view, that's really not that much use. From a controlling the fan speed point of view, however, we can mess about with the PWM signal. We just need something that will generate the PWM signal from within the computer. And as I've said before, I don't want to use the motherboard because the motherboard temperatures are not necessarily reflective of the temperature of the hard disks. I think I may have found a solution in this little device. This is it says on it, it's a PWM and pulse generator. So what we're going to do now is we're going to plug this in and see what comes out of it, and see if it will create the same sort of signal as my signal generator is creating. That is a 5 volt 25 kilohertz signal with a variable duty cycle. So this is the module running at 25 kilohertz. It's kind of jumping around a little bit, which I can't say I'm overly chuffed with. That's a very shitty signal, I suppose I would call it. I don't know if you can see on the camera the actual reading. Let's move this camera in a little bit and have a look. Yeah, the backlighting is a little bit crap as well. Okay, so it's running at 25 kilohertz, I believe. It looks like it might be 25 hertz, but I'm pretty sure it's 25 kilohertz. We can change the duty cycle here, I believe. And there you can see the duty cycle changes, and we can whack that down all the way to about where the fans stop running. I think we might just connect it up to the fan and see what happens. I don't particularly want to blow up my Be Quiet fans, but yeah. So admittedly I'm cheating a little bit here because I'm running the fan at 5 volts. So it is struggling a little bit to get started. But as soon as we get above about 30% duty cycle, it seems to work all right. There is definitely variability in the fan speed. Well, there you can see it in the camera. I was running the fan at 5 volts and then trying to control it with a 5 volt PWM, and I don't think it liked that very much. So I'm now running the fan at a proper 12 volts whilst using 5 volts for the PWM, and you can see that the speed control just works, and the fan just gets faster and faster. This is going to be the solution that I want, I suspect. But to be sure, what I now need to do is connect up this baby, which is a 10 fan controller. So we've now got the fan connected to the fan distribution system here and connected to the PWM generator here. You can see that it's running at 50% duty cycle. If we whop that right down, so at 10% it stops, around 15-16% it kicks off again. I'm not seeing a downside to this. This seems to work, so that's basically the slowest the fan will go. Essentially that's stop, isn't it? Because it's not blowing much air. I can whop it all the way up. So that's at 95% duty cycle, and I can definitely feel quite a bit of air coming out the back of that. And although the background noise here is overwhelmingly going to be my computer, I can tell you that that fan is only making very minimal amount of noise, which is fantastic. Probably more to do with the fan than my speed control. So the only other question is, will it load more fans? So my original plan is to have 3 fans, 3 120mm fans running, and as you can see there are 3 120mm fans running here. If we drop the duty cycle down a bit, I can definitely feel the airflow reducing, and we're down to 30% duty cycle. Really these fans are not doing anything. It's a very, very gentle breeze, but that's okay because most of the time they are going to be running I would suggest between 70% duty cycle and 100% duty cycle, really depending on how noisy they are once they're inside the case. If they don't make any noise at all, then they'll be running at 100%. But it does work And really all I have to do now is manufacture the means to mount it in the case. Well, I made a complete pig's ear of that, didn't I? I guess the moral of the story is don't let an oaf anywhere near a tube of superglue. I did actually manage to superglue myself to the front panel of the computer, but anyway, it is running, as you can see, and I can adjust the fan speed down, and hopefully you can see the fans are slowing down. Oh, that's a little bit too low. Which is grand. I have had a little bit of a rethink in terms of what I'm going to do, mostly because there isn't space in the top of the case for 3 of these units. There's only space for 2 with the hard disk attached anyway. So instead what I'm going to do is I'm going to replace the white fans in my computer case with more PWM fans. So that means basically I won't be using the voltage selector on the case anymore. It's all the fans that are not controlled by the motherboard will be controlled by this little unit here. So what I'm going to do is I'm going to unbox these babies, and I'm going to have 5 fans set up on the desk, all running through that unit just to make sure it all works before I start fitting it to the computer. It's pretty difficult to see the settings on this LCD, but you can see all five fans are now spinning quite happily, and you may be able to just make out that it's at 15% duty cycle, which is obviously not going to blow much air, but that's okay. We won't normally be running it this low, it'll be much higher. Now these fans, the new fans, are specifically airflow fans because I want it to be blowing air over the hard disks all the time. Hopefully it won't be too noisy, but let's whop up the duty cycle and see what happens. So the duty cycle's now at 50%. That should be going a bit faster. Can you see that? No. Can we zoom in on that? Oh, there we go. We can just about see that. Is there a focus button? So you can see the duty cycle's going at 50%, and you can see the absolute butchering that I did to the front of this panel once I'd stuck my hand to it. Anyway, let's up the duty cycle. So it's at 88%, and now things are starting to make noise. If I drop it down to so at 80% I can hear it. You probably can't. So at 70% it's not making much noise at all. Whether that's sufficient airflow I don't know, but I do think it'll probably make less noise once it's in the case. I think it's probably time for me to start thinking about shutting down the server and maybe fitting them. Yeah, why not? Yeah, I probably need to clean this fan filter, don't I? In the main drive bays here, I've spread out the hard disks as much as I can so that the airflow flows between them. And I've pulled out these little metal brackets that aren't in use and stuck them in the box. So I've mounted the PWM controller in the top bay on the front there, and you can see the hard disks with their fan attachments in the actual drive bays as well. The only other thing left is the fan controller itself, or the splitter, which is around the side here. And here's the said fan splitter mounted on the back side of the case where all the cable management is. All that's left to do really now is to plug it in and switch on the server and see what happens. Well, I guess that works then. Excellent. So the only other thing to do is to leave it running for a bit, and then I'll do my temperature checks again. And as we can see in the window here, they've dropped a bit, haven't they? Instead of being in the 30 degrees now, they're in the 20 degrees. The weather's a bit colder now, but I guess we'll find out summertime next year.